Hi all, welcome back. So today we will solve questions from complex numbers which came in different shifts of April 2025 attempt. In complex numbers we have total 9 questions, out of which 4 are easily doable, 4 are moderate and 1 is easy but lengthy, which we are going to solve. This difficulty level is basis my perception, which may be different for others. So let's move on to our first question. Before we have our first question, here is our analysis page for all the questions with the difficulty level. Hope this will be helpful for you. So here is our first question. Our question says, let z be a complex number such that mod of z is equal to 1. If we have this equation k belongs to R, then maximum distance of this point from this circle is. So first let's cross multiply this equation. We will get 2 plus k square z is equal to k square z, and z into z conjugate will be will be mod of z square plus k mod of z square, and our mod of z is equal to 1. So from here these two will get cancelled. Mod of z is equal to 1, so our k is equal to 2. Let's say our point P, which is k plus I k square, will be equal to 2 plus 4 iota. Now our max distance from point P to the circle will be distance of point P and the center of the circle plus the radius of the circle. So this is equal to, our point P is 2, 4, center is 1 plus 2 iota, so this will be under root of 1 plus 4 and plus our radius is 1. So this is equal to root 5 plus 1. So our answer will be option A. And here is our solution, and we can see that our answer is correct. Here is our next question. This time our question says, let z belongs to C complex numbers be such that we have this equation, then the sum of all possible values of z square is. So here in this question, first we will cross multiply in this equation and then move forward. So this will be z square plus 3 iota is equal to z into 2 plus 3 iota minus 4 minus 3 minus 4 minus 3 minus 6 iota plus 2 iota. So from here this will be z square minus z into 2 plus 3 iota, and then we will get plus 7. This will be minus 4 plus 7 iota. equal to 0. Now let's say this has root z1 and z2, and the question asks us of z1 square plus z2 square. So we can write this as z1 plus z2 square minus 2 times z1 z2. So from here z1 plus z2 square will be 2 plus 3 iota square, which is equal to 4 minus 9 plus 6 iota. 4 minus 9 plus 6 iota, and minus 2 times 7 plus 7 iota, this will be minus 14 minus 14 iota. So from here we will get, please wait a minute. Yes. We will get, we have minus 19 on the real side. Sorry. This will be minus 19 and minus 8 iota. This is 12 iota, sorry. 12 iota, 2, 4 minus 9, 3 into 2, 6 into 2, 12 iota. Yes, let's recalculate it. Minus 14, sorry, minus 19 and minus 2 iota. So our answer will be option B. And this is our solution, and we can see that our answer is correct. Here is our next question. This time our question says, if z1 comma z2 comma z3 belongs to complex numbers, are the vertices of an equilateral triangle whose centroid is z0, then we have to find the value of the sum. So first in this question, z1, z2, z3 are vertices of equilateral triangle, so we can say z1 plus z2 plus z3 is equal to 3 times z0, because this is an equilateral triangle. So this is an equilateral triangle, so all the sides will be same. Also we have one more property in complex number for equilateral triangle. So first let's square this. Both sides we will get z1 square plus z2 square plus z3 square plus 2 times z1 z2 plus z2 z3 plus z3 z1 is equal to 9z0 square. Now that property in complex number for equilateral triangle is that this expression, we can write this as z1 square plus z2 square plus z3 square. So from here we will get 3 times z1 square plus z2 square plus z3 square is equal to 9 times z0 square. From here this will be z1 square plus z2 square plus z3 square is equal to 3 times z0 square. So let's keep in mind this equation, and now let's find the value for the sum. So let's say this is S. Our S is equal to let's open it. So this will be, first we will have z1 square plus z2 square plus z3 square, and then we have three terms, so we will have 3z0 square or z0 square, and then we will have minus 2 times z1 plus z2 plus z3 into z0. So this will be 3z0 square. So 3z0 square plus 3z0 square is equal to 6z0 square. And z1 plus z2 plus z3 is 3 times z0. So this will be minus 6 times z0 square. And these two terms will get cancelled out. From here we will get s is equal to 0. So our answer will be option A. And here is our solution, and we can see that our answer is correct. Here is our next question. This time our question says, let A is equal to this set and B is equal to this set and S is intersection of A and B. Then we have to find the value of this sum. So let's say Z is equal to X plus iota Y. So we can write set A as X minus 2 square plus Y minus 1 square is equal to 9. This is from set A. And from set B we will have X plus Y is equal to 2. Now we can say Y is equal to 2 minus X. Substitute in the circle, we will get x square minus 4x plus 4. This will be 1 minus x, so plus x square minus 2x plus 1 is equal to 9. So from here this will be 2x square minus 6x minus 4 is equal to 0. From here we will get x square minus 3x minus 2 is equal to 0. X is equal to 3 plus minus under root of 9 plus 8, 17 upon 2. From here our y is equal to 2 minus x, so 4 minus 3, 1 minus plus root 17 upon 2. Now our, let's say this is s, so our required sum s is equal to 3 plus root 17 by 2 whole square plus 1 minus root 17 by 2 whole square plus 3 minus root 17 by 2 whole square plus 1 plus root 17 by 2 whole square. We will take 1 upon 4 common, and here from here 6 root 17 minus 6 root 17, so this will get cancelled. We will get 9 plus 9, 18, 17 plus 17, 34, and same for these two terms. So plus 1 plus 1, 2, and again 17 plus 17, 34. So this will be 88 upon 4 will be 22. So our S is equal to 22. From here, our answer is equal to 22. And here is our solution. We can see that our answer is correct. Here is our next question. This time our question says, if alpha is a root of the equation x square plus x plus 1 is equal to 0 and this sum is equal to 20, then n is equal to So here in this question, roots for this equation are omega square. Let's say alpha is equal to omega, then omega k plus 1 upon omega k square is equal to omega 2k plus 1 upon omega 2k plus 2 omega raised to power 3k is equal to 1. So from here, cross multiplying, omega 4k will be omega k plus 1 upon omega 2k plus 2. This is equal to omega 2k is 1 upon omega raised to power k. So this will be Please wait a minute. Yes. Omega 2k plus omega k plus 2. Now this will be 1 or 4. This will be 1 if k is not equal to multiple of 3. 4 if k is multiple of 3. So to find the n, let's start putting k is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's test it first 10. First k is equal to 10. Let's test for it. Please wait a minute. So k is equal to 1, we will get 1. K is equal to 2, again we will get 1. K is equal to 3, 4, same 1, 1, 4, 1, 1, 4, 1. Now let's calculate some 2, 4, 6, 7, 8, 12, 13, 14, 18, 19. So we need one more, k is equal to 11, 1. Then our sum will be 20. This is our S. Now our S is equal to 20. So from here, n is equal to 11. This n is equal to 11. So from here, our answer is equal to 11. And here is our solution. We can see that our answer is correct. Here is our next question. This time our question says, let the product of omega 1 and omega 2 be alpha plus iota beta. Iota is equal to root of minus 1. Let P and Q be the maximum and minimum values of alpha plus beta respectively. respectively. Then here we have asked P plus Q. P plus Q is equal to. So here in this question, first let's write omega 1 perfectly and the same for omega 2. Omega 1 is equal to 8 sine theta plus 7 cos theta plus with iota we will get sine theta plus 4 cos theta. Now omega 2 is equal to sine theta plus 4 cos theta plus iota 8 sine theta plus 7 cos theta. Now yes, omega 1 into omega 2 is equal to first real part, so this into this will be 8 sine square theta plus 28 cos square theta, 28 cos square theta please wait a minute. Yes. Then we will have 32 plus 7, which is plus 39 cos theta, sin theta cos theta. And minus of iota into iota part. Here in iota into iota we will get the same expression but with a minus. Because we can see 8 sin theta plus 7 cos theta into sin theta plus 4 cos theta, and we have the same multiplication with the iota side. So with a minus all the expressions will be same. 8 sin square theta plus 28 cos square theta plus 39 sin theta cos theta plus iota, with iota inside we will get this into this, so this will be 8 sin theta plus 7 cos theta whole square, which is 64 sin square theta plus 49 cos square theta, 7 into 8, 56 into 2, 112 sin theta cos theta plus sin square theta plus 16 cos square theta plus 8 sin theta cos theta. So from here, first these two expressions will get cancelled. So this is equal to 0 plus iota 65 sine square theta plus 65 cos square theta plus 120 sine theta cos theta. Now this part is alpha and this part is beta. So our alpha plus beta is equal to, now 65 sine square theta plus 65 cos square theta will be 65, because sine square theta plus cos square theta is 1, plus 60 times, we can write, we will take 2 from 120, 2 sine theta cos theta is sine 2 theta. Now our p is the maximum value, so p will be equal to 65 plus 60, 125, q is equal to 65 minus 65. So from here our answer will be p plus q is equal to 130. So our answer is option B. And here is our solution, and we can see that our answer is correct. Here in this question we have added p plus q is equal to, so here also p plus q is equal to. Now let's come to our next question. Here is our 7th question. This time our question says, among the statements S1, the set Z belongs to C minus, please wait a minute, this is iota, minus of iota, and here also these are iota, is purely real, z minus iota upon z plus iota is purely real, contains exactly 2 elements, and statement 2 says this set is purely imaginary, contains infinitely many elements. Sorry. So first let's move to statement 1. Now z minus iota upon z plus iota is purely real, so z minus iota upon z plus iota is equal to z conjugate plus iota upon z conjugate minus iota. So from here on cross multiplying we will get mod of z square minus z conjugate iota or z bar iota minus iota z plus 1, sorry, minus 1 is equal to mod of z square plus iota z plus iota z and plus iota z bar minus 1. So here these mod of z square and minus 1 will get cancelled. Now we can say z plus z bar is equal to 0. If z plus z bar is equal to 0, This means real part of z is equal to 0 and our mod of z is equal to 1. This is given in the statement. So for mod of z to be equal to 1 and real part of z to be equal to 0, our z can be minus iota and iota. But in the question, we have excluded minus iota and accepted iota. So here we have only one element. But the question says we have exactly two elements. So from here, S1 is wrong. Wrong. Now statement 2. Statement 2, z minus 1 upon z plus 1 is purely imaginary. So z minus 1 upon z plus 1 plus z bar minus 1 upon z bar plus 1 is equal to 0. On cross multiplying, we will get mod of z whole square minus z bar plus z minus z bar minus 1 plus mod of z whole square z bar minus z and again minus 1 is equal to 0. Now our mod of z is equal to 1. So the mod of z square and minus 1 will get cancelled here also. And here z minus z bar and z bar minus z will also get cancelled. So 0 is equal to 0. This means S2 contains infinitely many elements. So from here, our S2 is correct. So our answer will be option C. Only S2 is correct. And here is our solution. We can see that our answer is correct. Here is our next question. This time our question says, now here also in this question, this is not 1, here we have iota. Iota and iota. Now let's come back to our question. Our question says if the locus z belongs to C such that real part of this plus real part of this is equal to 2, is a circle of radius r and center a comma b, then we have to find the value for this expression. So please wait a minute. Yes. Now here is also one more thing in the question which we can see, z minus 1 upon 2z plus iota is conjugate of z bar minus 1 to z bar minus iota. So from here, we can say real parts of this expression and this expression are same. So 2 times real part of z minus 1 upon 2z plus iota is equal to 2. 2 will get cancelled. Let's say z is equal to x plus iota y. Then we will get real part of x minus 1 plus iota of y upon 2x plus iota 2y plus 1 is equal to 1. From here we will rationalize with respect of denominator. We will get x minus 1 plus iota of y and 2x minus iota 2y plus 1 divided by 2x plus iota 2y plus 1 into 2x minus iota 2y plus 1 is equal to 1. So from here, let's directly now write the real part, which will be 2x square, or let's write 2x x minus 1 plus 2y plus 1 into y divided by 4x square plus 2y plus 1 square is equal to 1. So from here this will be 2x square minus 2x plus 2y square plus y is equal to 4x square plus 4y square plus 1 plus 4y. Please wait a minute. 2y plus 1 and 4y. Yes. From here we will take this to the right hand side. We will get 2x square plus 2y square plus 2x plus 3y plus 2x plus 3y plus 1 is equal to 0. Now dividing by 2 on both sides, we will get x square plus y square plus x plus 3 by 2y plus 1 is equal to 0. Plus 2x, 3y, yes. So from here, our center is equal to minus half minus 3 by 4 comma r is equal to under root of 1 by 4 plus 9 by 16 minus 1. So from here this will be 4 by 16 plus 9 by 16. Please wait a minute. Please wait a minute. Yes, yes. 4 plus 9 minus 16. Y 3y, and here we have 2x. 1 4x square, 4y square plus 1 plus 4y. 1 upon 4 plus 9 upon 16. 3 upon 4, 1 upon 2. Please wait a minute. Here we have 9 upon 16, and this will be 13 minus 16, negative. Please wait a minute, here we have some mistake. 2x square plus 2y square plus 2x and plus 3y plus 1, 3 by 2. And this will be 1 by 2. Sorry. Here we will have minus 1 by 2. Sorry for the mistake. Now let's come back. 13 upon 16 minus 8 upon 16, which will be 5 upon 16. So this is equal to root 5 upon 4. Now our question asks us about 15ab upon r square. This is equal to 15. Minus minus will get cancelled. 1 upon 2, 3 upon 4 into, please wait a minute, 15 into 1 upon 2 into 3 upon 4, 5 upon 16, so into 16 upon 5. So here 5 will cancel 15. 3 times 2 and 4 will cancel. 16 2 times. So this is equal to 18. From here our answer is option C. And here is our solution, and we can see that our answer is correct. Here is our next question. This time our question says let A is theta is between 0 to 2 pi, and we have real part of this expression of this complex number. Then we have to find the value of this sum. So let's say this complex number is z. So our z plus z bar is equal to 2 times real part of z. So z plus z bar. Now let's calculate z plus z bar, which is 2 cos theta plus iota sin theta upon cos theta minus 3 iota sin theta plus 2 cos theta minus iota sin theta upon cos theta plus 3 iota sin theta is equal to 2 times real part of z. Now real part of z is minus 1 upon 10, so this will be minus 2 upon 10. Now let's cross multiply. We will get 2 cos square theta. First let's write real parts of both of these two terms. 2 cos square theta minus 3 sin square theta and plus 2 cos square theta minus 3 sin square theta. Now for the imaginary part, 6, 7 and here also minus 7. Here we will get plus 7 sin theta cos theta with iota, and here we will get minus 7 sin theta cos theta with iota. So that parts will get cancelled and divided by denominator into denominator. This will be cos square theta plus 9 sin square theta is equal to minus 2 upon 10. From here, these term 2 times 2 cos square theta minus 3 sin square theta. 2 will get cancelled. We will get 2 cos square theta minus 3 sin square theta upon cos square theta plus 9 sin square theta is equal to minus 1 upon 10. Now on cross multiplying, we will get 20 cos square theta minus 30 sin square theta is equal to minus cos square theta minus 9 sin square theta. From here we will get 21 cos square theta and minus 21 sin square theta is equal to 0. We will take 21 and take it to the right hand side. Left hand side we will get cos 2 theta, right hand side will be 0. So 2 theta can be, for it to be 0, and 2 theta is between 0 to 4 pi because theta is between 0 to 2 pi. So this will be pi by 2, 3 pi by 2, pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2. So from here our theta is equal to pi by 4, 3 pi by 4, 5 pi by 4, 7 pi by 4. So from here, let's say this is our S. So our required sum S is equal to 1 upon 16. Let's take 1 upon 16 common with pi square. Inside we will get 1 plus 9 plus 25. Please wait a minute. 9. 1 plus 9 plus 25 plus 49, which will be 50. 10, 10, 35. Please wait a minute. Yes. Sorry. We will have 49 plus 35, which will be equal to 184 upon 4. We will get 21. So our S is equal to 21 pi square by 4. So from here our answer is option A, and here is our solution, and we can see that our answer is correct. So hope you found this video helpful. Thank you for watching.